Is trig functions of any angle. Okay, this is section 4.4. I broke the notes into two parts. We're going to do the first part today, second part tomorrow. If I gave you a theta.
You mean Monday?
Whenever we have school. Yes, Monday. I mean, obviously, I'm not going to teach you on Saturday, but thank you for correcting me. It's okay. It's been a long one already. If I gave you theta is pi over 3, you guys would go to the unit circle. You would find the ordered pair, and then you would tell me the sine is, what the cosine is, all that stuff. What we're talking about now is trig functions of any angle, not a specific angle that lies on the coordinate plane, on the unit circle. All right. What you're going to be given is an x, y, and a y value. X value, y value. You're going to have to find the r, which happens to be the hypotenuse. If you look at this formula right here, all this is the Pythagorean theorem, just uses different letters. These are the trig functions you already know. If I gave you something that was on the unit circle, you would tell me that the sine of that is the y value of the ordered pair. You would tell me the cosine of that angle is the x value of the ordered pair. You would tell me that the tangent is y over x. So this is nothing new. All this is what we're doing in a sense is drawing something called a reference angle. If you guys notice, you see this big angle right here? This is theta, right? That's not a right triangle. But we can form a right triangle by drawing a vertical line from the end of the terminal side down to the x-axis, and we can form our own little right triangle here. Does everybody see that? This is our angle of reference. This is going to be my y value. The up and down is your y. The left and right is your x. So if you were going to find the third side, obviously you're finding the hypotenuse, which in this case is labeled r. Now, if this is my theta, and I said to you guys, what's the sine? Well, sine is what? Opposite over hypotenuse, right? It would be opposite over hypotenuse. This is the same trig functions that you guys have talked about with SOHCAHTOA. Exact same thing. You're just given an ordered pair, so they're talking about x and y. All right, so we're going to go through some examples here, and you're going to see, oh my gosh, this is really easy. I hope we have a bunch of these on a test. Tuesday, December 15th, we are going to test over Chapter 4. It's going to be a majority. It's going to rely heavy on sections 4.4, which is what we're doing today and Monday, and 4.5, which we're going to be doing Tuesday, Wednesday, Thursday of next week. But it will have some elements from the first few sections just to make sure, because it's really important that we can hone in on our trig functions.
Yes, madam.
Uh-huh.
Did you post homework on this yet?
No. I'm giving you guys the weekend off.
Oh, thank God.
Sure. No problem.
Bless your soul.
Yes. See? I'm not that bad. All right, so what we're going to talk about more on Monday is reference angles and stuff like that. But if you are given this information, you can find the trig functions. They have given us, what I'm going to show you now is you don't even need a triangle. You don't need a picture. You guys can just figure this out on your own because they give you an x and y. They gave me that the y value is 4, the x value is -3, so I have to find r, the hypotenuse. Right? So you can write down, this is what I expect you guys to do, x equals, y equals, r equals. X is, what's the x value? -3. Y is 4. I'm going to find r. So I'm literally going to say -3 squared plus 4 squared equals c squared. -3 squared is 9. 4 squared is 16 equals c squared. 25 equals c squared. So what is my r, or r, whatever you guys want to call it? What is the hypotenuse? 5. Now that you have figured out these three values, your trig functions are super easy. Our sine of theta is the y value, which it usually is the ordered pair, over your hypotenuse. Your cosine is the x value over hypotenuse. Your tangent is, like we've talked about a million times, y over x. This first question just asks for those three trig functions. So we literally will take our numbers. So y is 4. The sine of this is 4 over 5. Cosine is -3 over 5. Tangent is what?
4 over -3.
There you go. That's it. Literally that easy. We're going to talk about on Monday a little bit on how to find the signs, because it'll tell you like what angle the quadrant what quadrant the angle lies in, and we'll talk about that a little more on Monday. But nothing you guys can't handle. Computational wise, the most math you're going to have to do is either the Pythagorean theorem or rationalizing a denominator. These next few sections, there's lots of thinking, lots of putting things together, but there's not a lot of math computation. Question? Examples. We got this. All right, we're going to do 4 examples. 2 of them are going to give us pictures, 2 of them are not. But the pictures don't matter, because I need 3 pieces of information. I need an x value, I need a y value, and I need an r. They're always going to give me here, guys, the x and the y. How do you find the r? It's the Pythagorean theorem. 4 squared plus 3 squared equals r squared. 16 plus 9 equals r squared. 25 equals r squared. So r equals 5, correct?
Yes.
So you're going to write down x is 4, y is 3, r is 5. And you take that information to do all 6 trig functions. Sine of theta is y over r. Cosine theta, x over r. Tangent theta, y over x. So if you had to do this on a WebAssign, this is you showing me your work. Not writing me a note that says, I did it all in my head. I don't give credit for I did it all in my head. Those of you who keep doing that, you keep getting bad grades. Stop doing that. Secant is r over x, just the reciprocal. And cotangent of theta is x over y. So, taking our numbers that we have, let's figure out our trig functions. Sine of theta is what over what?
3 over 5.
Thank you, sir. 3 over 5. So that means my cosecant is what?
4.
No, cosecant.
Oh, cosine.
5 over 3. Good. So now let's do cosine. Cosine is?
That's 4 over 5.
That's 4 over 5. So that means my secant is?
5 over 4.
5 over 4. All right, let's look at the last one. Tangent is what?
3 over 4.
3 over 4. So my cotangent is?
4 over 3.
Wow, was that incredibly difficult?
No.
Ladies and gentlemen. No, it was not. So we can handle this, guys. That's why we did this on a Friday half day. Look at this next one. Okay, I need to know 3 values. I need to know the x, I need to know the y, and I need to know the r, correct? So let's figure it out. I already know 2 of them. I know that x is -8 squared, and I know that y is 15 squared. So ladies and gents, please remember, when you square a number, whether it be negative or positive, what does it become? Positive. So r should never be negative. If you guys give me negatives, that's a problem. But -8 squared is 64 plus 225 equals r squared. 64 and 225 is 289 equals r squared. Does anybody know what the square root of 289 is? 17. So r equals 17. Do you think all the ones that I'm going to give you on your test are going to be nice and pretty like this?
Absolutely not.
Probably not, no. But, you know, just trying to build your confidence a little bit as we go through this. You guys are going to have to really be careful on signs, right? That -8 makes a huge deal. It changes which quadrant that the angle is that we're talking about. So just pay attention to little stuff so you don't get little stuff wrong. So my sine of theta, remind yourself if you need to, is y over r. Cosine of theta, x over r. Tangent of theta, y over x. You guys don't have to write this every time, but I think at the beginning here, to just kind of give yourself a little reminder, is a very good idea. R over y, secant x over, r over x, and then cotangent x over y. So, ladies and gents, do this with me. Come on. What is the sine of theta? What's the sine of this angle?
15 over
17.
Perfect. So that means my cosecant is?
17 over 15.
There you,
15.
perfect. Cosine?
-8 over
-8 over 17.
Good. Secant?
17 over negative 8.
Perfect. Tangent.
15 over negative 8.
Cotangent.
Negative 8 over 15.
Awesome. Good job. Deanna, you got it, babe? All right, how are these two a little different?
Oh, they don't give you a graph.
There's no picture, there's no graph. So if I give you an ordered pair and say, find the, here's a terminal side of an angle standard position, determine the exact values. You should not be like, what? Think about what I'm giving you.
Oh, the picture is
Just draw a triangle.
You don't even need that, guys. You don't even need it.
Yeah, do that.
Look, they give me my x value and my y. So I can write down x equals negative 4, y equals 7. What's the missing piece that I need?
R.
I need r. Do I know how to find r?
Yes. Yeah.
Negative 4 squared plus 7 squared equals r squared. 16 plus 49 equals r squared. 16 and 49 happens to be 65 equals r squared. Take the square root. R equals square root of 65. We should check here to make sure that we can't break this down. This doesn't, but if it did, we would need to break it down into a perfect square and a non-perfect square. But here's the only information we need. We don't need anything else. We don't need a picture. We don't need SOHCAHTOA. All I need is this information. So now I'm going to do my 6 trig functions. I'm going to say the sine of theta is y over r. Cosine theta, x over r. Tangent theta, y over x, right? Then I have cosecant, which is r over y. Secant, x, keep doing that. R over x. And then cotangent, which is x over y. Okay. Remember, Webasine, radicals in the denominator, okay. Mrs. Meadows, not okay. So the sine is y over r. Can I leave my answer like that?
Nope.
No, I have to rationalize top and bottom by root 65. So my answer becomes 7 root 65 over 65. What's my cosecant?
Root 65 over 7.
Perfect. Okay. What's my cosine?
Negative 4 root 65 over 65.
So I have to rationalize. Negative 4 root 65 over 65. What's my secant?
Root 65 over negative 4.
Perfect. What's my tangent?
7 over negative
7 over negative 4.
Perfect. What's my cotangent?
negative 4 over
Negative
7.
4 over 7.
Perfect. Good job, guys. Very good job. How do we feel?
Pretty good.
Okay. Nick, you good? Okay, last one. Here we go. What did they give me?
X and Y.
They gave me x. They gave me y. So I'm going to write down real quick. X equals 3. Y is negative 4. Do you guys already know what r equals?
Yeah, 5.
Yeah, but we'll just work it out real quick. So you can say 3 squared plus negative 4 squared equals r squared. 9 plus 16 equals r squared. 25 equals r squared. R equals 5, yeah?
Yeah.
Okay, so let's run through our trig functions, and we are finito. I have sine of theta. Remind me what sine of theta is again?
Y over r.
Thank you, sir. Cosine of theta.
X over r.
Good. Tangent of theta.
Y over x.
Perfect. So my reciprocal functions would be cosecant of theta is
R over y.
r over y. Good. Secant theta.
R over x.
Yep. And then cotangent theta.
X over Y.
X over Y.
Awesome. Now this part, guys, you just throw them in. Y over R. Make sure you pay attention to your signs. So y over R would be negative 4/5. So my cosecant would be?
5 over negative 4.
Perfect. Cosine is x over R, so 3 over 5. So my secant is?
5
5 over
thirds.
3.
Perfect. Tangent, y over x.
Negative 4.
Negative 3.
4 over 3, good. So then cotangent is?
Negative 3
over
fourths.
negative 4.
Perfect.
3 over negative 4.
Perfect.